We're going to do these last two examples. So we're solving by elimination. We're going to have to multiply both of the equations. So let's start with this one. I'm going to try and eliminate the x's. So let's look at 2 and 9. The least common multiple between 2 and 9 would be 18. So I want one of them to be positive 18x and one to be negative 18x. So multiply the top one by negative 9. That would give me negative 18x. And I'll multiply the bottom one by positive 2. Okay, remember you always should rewrite after you multiply. So after I rewrite, this becomes negative 18x. Ooh, what's that? Plus 54y equals negative 72. And then the one below that, I'm multiplying everything by 2. Positive 18x, negative 54y, and positive 36. So now I can add up these two equations. And when I do that, my x's eliminate, but so do my y's, which means that over here on the left-hand side, I'm just left with 0, because you have to put something. If you add up the right-hand side, you get negative 36. Okay, this is a special one, remember? So 0 is not equal to negative 36. So you would say no solutions. This is going to be lines that actually are parallel if you were to graph them and never intersect. Last one, again, you are going to have to multiply both equations. I am going to eliminate the y's this time. You could do either. But if I want to eliminate the y's, my least common multiple between 6 and 9 is 36. So that means I have to multiply the top one by positive 6. That would give me positive 36y. If I multiply the bottom by positive 4, that would give me negative 36y. Let's rewrite that and multiply everything on the top by positive 6. So I get 24x plus 36y equals 48. We'll multiply the bottom equation by 4 and get negative 24x minus 36y equals negative 48. And we're going to add those up. Again, both my x's and my y's will cancel out because they add to 0. So I have to put something, so I'm going to put 0. And on the right, I also add those up and get 0. 0 is equal to 0, that's true, and so because this is a special case, this is going to end up being infinite solutions. As you can see, these are literally the exact same equation, or at least they would be if you multiply by negative 1. So since they're the exact same equation and you end up with 0 equals 0, which is true, you say infinite solutions.